Hi, my name is Dagny and I'm a sophomore in computer science, and here at Mines I'm involved on the swing team and in ACMW. And I study computer science because I love solving problems with code. I welcome you to this CS at Mines Python video. Today we're going to talk about the basics of random number generation in Python. But first, let's start with a good quote. The generation of random numbers is too important to be left to chance. Once you understand that computers can't actually generate random numbers, then you understand why this quote is pretty funny. Computers generate pseudo-random numbers that seem random, but in fact they're not actually random. In other words, computers don't actually generate random numbers by chance. So, how do we generate a pseudo-random number in our program? Let's take a look. Python has a nice library that you can use to generate a pseudo-random number. You first need to import the random library into your code with the command shown. Then, to generate a random integer, we use the randint function. This function returns a number between a and b inclusive, which means that a and b can be chosen as a random number. Notice how the dot operator is used to call the randint function on the random object. To generate a random float, we use the random function, which returns a number between 0 and 1, exclusive of 1. This means that 1 cannot be chosen as one of the random numbers, but 0.9999 can, for example. So, to get a random number in your program, you need to import the random library and call one of these two random functions. Both of the random functions return a random number that you can then assign to a variable, as the example shows on this slide. In other words, when this code is executed, randNum will be a random floating point number between 0 and 1. Let's consider a few more examples. How do we generate an integer that ranges from 1 to 10? This example is a direct application of the randint function. How do we generate an integer that ranges from 0 to 7? Once again, we do this via the randint function. The next one is a bit more complicated. We know we can generate a random float between 0 and 1 using the random function. So, how do we generate a random float between 0 and 5? Smart. We just need to multiply our random float by 5. What if we want to generate a random float that ranges from 1 to 6? How would we do that? We just need to add 1 to our previous example, which offsets our number to the desired range. Hopefully these examples make you realize you can generate any random number that you might want given some specific range. The purpose of this slide is to show how to generate several random numbers. Notice these examples are each in a for loop, which shows we can generate several random integers or floats in a given range. One thing to note. Notice how the random library is only imported into your program once. You only need to bring the library in once, not each time you generate a random number. Usually, you do these types of import commands at the top of your code. Here's something else to consider. If we executed the code on this slide a second time, would we get the same random numbers? It is unlikely that we would, as that wouldn't be very random, would it? But what if we do want to get the same random numbers each time we execute our code? For example, often when you are testing your code, you need the same random number generated at each execution. That's where the seeding comes in. Notice the seed function called in this code. With a seed of 54,321 and the pseudo-random generator function used currently in idle, this code will print 3 each time it is executed. To extend the previous example, check out the output of this code. 5 random numbers are generated twice due to 2 for loops. Does the output look random? Not really, as the same 5 numbers are generated in the second for loop. How did that happen? Notice in the code how the seed function was called twice, first at the top of the file and then again after the first for loop. Each time the seed function is called with 54,321, the next random number generated will be 0.488669, etc. Again, the random number generation is not really random. It's pseudo-random, and we use the seed function in order to get the same stream of pseudo-random numbers generated. This is especially needed when testing your code. Now it's your turn. We encourage you to pause the video and write down each line of code you need for the various examples. Then, create a new Python file, import the random library, and type in the code you wrote down. Lastly, add print statements for each random number generated and execute your code. You'll then be able to see if you generated the requested random number in each of the provided ranges. Let's look at some other code that generates random numbers. What does this code block do? We encourage you to pause the video and trace through the code to figure it out. Once you think you have a good idea of what is going on, type the code into a Python file and execute it to see what happens. Here's another example. What do you think this code block does? Pause the video to figure it out. Then type the code into a Python file and execute it to see what happens. Were you surprised by the answer? I think this one was a tricky one. Let's look at one more example. See if you can figure out what is wrong with this code. Pause the video and analyze what is going on. The error might not be obvious. Okay, let's think this through together. In essence, this code block is choosing 5 random letters from the alphabet and creating a random string from those letters. The error here is tricky because it is not guaranteed to happen every time we execute the code. When I first executed the code, JPIIU was printed. The second time, KJRWA was printed. Then, after several executions, I received a runtime error. The issue is because we added 1 to the length of the alphabet. This means that the random number generated has the opportunity to go out of bounds of the alphabet string in some executions. This only happens some of the time. Most of the time, our index is fine. This type of error is hard to debug, as the output of our code is always changing. Make sure you are extra careful when using random functions in scenarios like this one. We hope you now have a good understanding of random number generation in Python. We encourage you to practice using these functions to fully understand them. Random numbers are very important in computer science. Think about what you can do with them. Thanks for tuning in. See you around campus.